need more time? Okay, well, can anyone dictate then? 12 squared. Okay, I agree. Good. So 144 plus 25 equals x squared, or x squared equals 169. What do we do now? We take the square root. How many solutions do we have to write? I have to write them. Yes, that is 13. However, since it's a distance, it's only 13 feet. Any questions on this? Perfect, excellent. Last section of this chapter, 10.7, complex numbers. Complex numbers. Now, first of all, don't we have enough numbers from negative infinity to infinity? Do we need more numbers? No, I agree. However, there are certain things that we cannot do with real numbers. So we had to create, not me, very, very long time ago, they came up with complex numbers. And they said, okay, this is a bigger set than real numbers. Where was the need? Why we needed complex numbers? And here's the answer. So the question is why? Why complex numbers? So let's say we have the following equation. What would you to solve? What would you tell me to do? Wonderful. Move 4 to the other side. So then I have x squared equals? Good. This is impossible using real numbers. Impossible. Why? What type of number is this no matter what I plug in there? Good. What type of number is this? So I'm telling you that a positive number equals a negative number, which cannot happen using real numbers. So then, going back to the same step, when we take the square root from both sides, how many solutions will we get? Very good. So x equals plus or minus. I am going to split. There is no such thing. A square root of negative 4 does not exist. So this will be the square root of negative 1 times the square root of 4, as we know from this chapter. I know the square root of 4 is, now this will have a special name. It's called, first of all, is denoted by I, lowercase I. And lowercase I, which is the square root of negative 1, represents the imaginary unit. Therefore, the solution of this equation is x equals plus or minus 2i. What does this have to do with complex numbers, and how do complex numbers look like? What do they look like? So complex numbers look like this, where a is called the real part, and this is the imaginary part. Of course, a and b are real. This is lowercase I. So complex numbers are a plus bi, where a and b are real numbers, and of course I is the imaginary unit. So complex numbers are composed of two parts, a real part and the imaginary part. Can I write a real number? If you noticed, I put the real numbers inside complex numbers, which means complex numbers are bigger than real numbers. Can I write any real number as a complex number? Perfect. How will I write a real number? Let's say 10. How do I write 10 as an imaginary number? Say it again. So 10 plus 0i. 10 has to equal 10. If I put 10, that will never equal 10i. Correct? So 10 is, this is the real part and this is the imaginary part. Now, can anyone give us an example or two examples of complex numbers? Just give us two examples of complex numbers. A and B are real numbers. Any real number you want. 1 plus I. Excellent. That's one complex number. Excellent. Let's make up another one. Negative 2 plus 3i. Good. Yes, please.
How can you do 1 plus I, but you can't do 10 plus I?
No, the question was, how do I write 10 as a complex number?
Right.
So if I write, so you wanted to write 10 equals 10i?
No, she's saying, why is there 0 out there when you have 10?
Because if this is not 0, then 10 will not equal 10.
So it's 1 plus 0i.
Correct.
Alright.
Yeah, because if I don't put 0, then 10 will never equal 10 plus 2i, for example. That will never happen. Good. So we found two complex numbers. We want to learn how to add them, subtract, multiply, and divide. So we're looking at operations with complex numbers. And you made up two complex numbers. Let's add them up. So addition of complex numbers. 1 plus I plus negative 2 plus 3i. So what do I have to write? Of course, parentheses can be removed, right? So it's 1 plus I minus 2 plus 3i. All I have to do is combine like terms, and I have to write the real part first. Yes, perfect. Plus, that's it. This is how we add complex numbers, simply combining like terms. We are going to use the same numbers and subtract them. Two complex numbers that you gave me. So I'm copying 1 plus I. What will I copy next? Very good. Again, we combine like terms. What do we get? Very good. 3 minus 2i is the difference of these two complex numbers. Any questions? Stop me if you have questions, please.
So we have to do, it has to be, you said 2?
You wanna add 3? We can add 3. In order to illustrate addition or subtraction or multiplication and division of complex numbers, it's sufficient to have 2. We pick 2. Very good. Now let's multiply. Before we multiply two complex numbers, let me remind you, let's write it one more time. What is y? I'm sorry, what is I equal to? Now please square the left-hand side. Good. And the right-hand side? Please square the right. So that's all we have. So please remember, I is the square root of negative 1 and I squared is negative 1.
Wait, so I actually use the square root of negative 1?
That's, here it is. The square root of negative 1 is I. I squared is negative 1. So now I'm going to copy the same numbers you gave me. You gave me 1 plus I multiplied by negative 2 plus 3i. Good. Ready? Can you please tell me what to write? Perfect. You distributed 1 to negative 2. Excellent. 1 distributed to 3i plus 3i. I distributed to negative 2 minus 2i. And I distributed to 3i. Very good. For everyone to see, you're correct. You're way ahead of us. Perfect. Okay, but now we know that this equals how much?
-1.
-1. Therefore, I have -2. How much will this be? -3. And how much will this be? Sine plus I. So finally, -2 minus 3, that comes from here. -2 minus 3 is plus I. So this is the product of the given complex numbers. Let's finally look at division. Let's see how we divide two complex numbers. We have the same complex numbers you gave me. Like with rationalizing the denominator, we have to use the conjugate. Let's use the conjugate. Can anyone give us the conjugate? As if we are rationalizing. Of course, we're not. As if we were rationalizing.
Oh, for the denominator?
I can change the first term. That's not the conjugate. -2 minus 3i. -2 minus 3i. Perfect. Now the reason is, and I would like to write a note here for you so to understand why we do that. Note, when multiplying two complex conjugates, the answer is always, leave some space. We'll figure it out in a minute, and then you'll tell me what to write. So when multiplying two complex numbers that are conjugates, two complex conjugates, the answer is always, and we'll figure it out in a minute. So remember the formula. It's the second contract we had. A plus B times A minus B. What do I write in the denominator? Good. Minus mandatory is the difference of squares. Minus 9.
Oh.
Very good. 9i squared. Perfect. So now what do I do with the top? I have to distribute. I have to FOIL. 1 distributed to -2. What do I get? Perfect. 1 distributed to -3i. Very good. I distributed to -2. And I distributed to -3i. Excellent. Couldn't have done it better. Perfect. So now I know that this is, and I know that this is perfect. So what will you tell me to write? So this is +3 with -2. +3 minus 2, 1. -3i minus 2i. -5i over 4. -9 times -1. The denominator, I have to split it in order to show the real part minus the imaginary part. What is the first part? Over minus over. Good. So then, now let's come back to what we left off here. When multiplying to complex conjugate, the answer is always what type of number? Say it again.
even number?
Very good. Always. That's the reason why we multiply and divide by the conjugate of the denominator, to make the denominator into a real number so I can split it at the end. Very good. Now the last thing that I want to show you that is new before we look at more examples is powers of I. Powers of I. So please give me a power of I. Anything, any number that you can think of. Which one? Yes, I'm sorry.
Just a question. That I at the end, is that just
Multiply. So it's 1 over 13 minus 5i over 13, but I put it outside. But you can put it at the top, but we like to write this. So I have to identify this and I outside, but it's multiplied. Very good question. As I said, I always encourage my students to ask any question because I may do something that I don't clearly say or present, and I want to be as clear as possible. Okay, give me a power of I. Any power you want. You want 3? Okay, let's say 3. I'm sorry? You said 31? No, of course not. So all I know is that I is the square root of -1, and I know that I squared is -1. That's all I know. So all I have to do is relate to these. So I know that 3 is not divisible by 2, but if I split it as I squared times I, then I know what this is. So I cubed is I squared times I. What is I squared?
-1.
So -1 multiplied by I is -I. And this is it. We cannot further simplify this. What about I to 2016? I see that this is an even number, so I'm going to write y squared raised to a power.
Can you just make it 16?
You mean instead of 2016? It's the same thing. You'll see in a minute. We will look at 16. We will look at 16 in a minute. So, can anyone give us the power here? And can anyone explain what operation you perform? Say it again. 1008. I agree. What power? What operation did you perform? Just explain. Right. We divided by 2 because whenever I raise an exponential notation to a power, I copy the base and multiply the exponents. We know that from the previous course. But I know what I squared is. What does I square? -1. Now I raise a -1 to an even power. What will I get? How much?
No, just 1.
Just 1, indeed. This is it. Just 1. Any? The I to the 16 would be I to the second power raised to the 8th power. -1 to the 8th would be 1. There are 4 possibilities. For I to any power, all i's to any power will convert into 4 possibilities. +1, -1, positive I, and negative I. You cannot get anything else but 1, -1, I, or negative I. So let's look at another power of I. Okay, so we want to look at 5. Again, 5 is not divisible by 2, so I have to split into I to the 4th power times I. So I have I squared, which is squared times I. How much is I squared? Well, -1. And that's 1 times I, which is I. What about I to the 10th power? So this is I squared to which power? Yes, very good. And I know I squared is negative 1 raised to the 5th power would be negative 1 indeed. Okay, on page 640, I would like to start with problem 24.
I have a question.
Please.
Is there another way to find it other than like that? Because I remember when I learned it the very first time I learned it, which was like a long time ago, there was a way to find it.
Your book does not really present a method. So your book just says, okay, finding powers of I, you can use this fact and to hire this, and they just list powers.
Right.
So if that is better for you, you can use it. I accept any method.
Oh, I see. See, that's what helps me. It's like the 1 through 4 and then the 5 through 8. Like just because it like just cycles over again instead of trying to like
But
figure it all
but
out.
I personally think that I will never memorize this. I don't care for it. I know that the only thing that I have is I squared.
Can you zoom in on that? I'm sorry. Can you zoom in on the bottom part? You know what I'm talking about?
Yes, I know. Why would you memorize something like this? But it's up to you. As I said, I accept it, but you still have to show some work. Because if the answer is negative 1, but you put positive 1 and you don't show any work, I won't be able to give partial credit. So it's fine if you.
I don't know. I just feel like learning it in variables of 4.
That's fine. It's up to you. I'm okay with that. But you still have to show some work, because if you write I to the 10th and you memorize something and you write positive 1, I won't be able to give any credit because I to the 10th is negative 1. So I want you to pay attention to that, because I always like and I always want to give partial credit. I think that this method is always going to be easier in my opinion, because you know that I squared is negative 1. And you will not memorize anything. But if that is better for you, I accept it. Okay, 24 on page 640. The square root of 49 divided by the square root of negative 10. Any questions? Rebecca, is that better?
No, it's fine.
You would like to use the formulas, those sets?
It's like a scale, isn't it?
I just know that like I to the 10th would be like in variable 4 would be like I to the 8 plus 2. So like I to the 8. Never mind. I got it. So I'll just do it.
But what you were saying, you're not going to get negative 1 by
No,
what
I
you
got
just.
negative 1. But it's
Okay. Yes, Ryan, go ahead.
Alright, I know 7's on the top.
Right? No, I thought you wanted to say something. I'm sorry. I don't like to pick. I don't pick on anyone.
No, it's cool. Okay.
I thought you had a question or something.
No.
Sorry about that. Okay. Okay. So what about the denominator? I'm sorry. Yes. How? Excellent. Yes. That will not help. Okay, this is how we started this section. Okay, we said the square root of negative 4 is the square root of negative 1 times the square root of 4. I have to do that first. So, anyone?
square root of negative 1 times
Very good. Good. The square root of 10 cannot be further simplified for now. So then what do I have in the denominator? Yes? Good. What did we do before with something that has a radical in the denominator? How is the procedure called and what do we do? Excellent. The denominator. So how do I rationalize it? By? In order to rationalize the square root of 10. We have not talked about I yet. In order to rationalize the square root of 10, I must multiply and divide by, of course, the square root of 10. Perfect. So then the top is 7, the square root of 10. What about the denominator? How much? Very good. Now, since I'm dividing by I, this is like, if you want, I can separate it. I prefer writing it like this. So this is like 0 plus 1i. And I need to divide. And I divide, multiplying, I divide two numbers, especially the complex number in the denominator, using the conjugates. So what will be the conjugate of this? I separated them because they're a product. I can put 1 over 10 in front. I put 1 over 10. So we don't have to worry about 10. But you don't have to. If you would, you can put a 10 in there. It's still the same thing. So what will I multiply and divide by? Negative I. That would be enough. I wouldn't even bother with the negative, to tell you the truth, because there is nothing in front. Just I. So then the numerator is 7i the square root of 10. What about the denominator? When you multiply I by I, you get I squared, and which is times 10. Very good. So then I will just put the negative in front. 7i the square root of 10 over 10. Look at it and see if you have any questions. Yes, of course. What was not clear here? Oh, yes, of course. Let's do another. Yes, Ryan, go ahead. Okay.
Is it okay to just put negative on the 10?
If you want to. Oh, in the denominator?
Yeah.
No, you cannot leave it. Because you are dividing a positive number by a negative number, so the final form has to have minus in front. Yeah. Okay, let's say 23. We have the square root of negative 9 divided by 3. What do I have to do first?
Square root of negative 1, square root of 9 over 3.
Very good. And how much is the square root of 9?
3.
And how much is the square root of negative 1? And what will you do to find the final simplified form? Divide by? Divide by 3. So the final answer is I. Okay, let's look at 25. Any questions? The square root of negative 80 divided by the square root of negative 10. So what will you tell me to write as the next step? Yes? Yes, that is correct. Yes, Ryan? Yes.
Conjugate? I mean, I wasn't trying to solve it all day.
Conjugate, you have to have two terms. Or at least one term with I in it.
Okay.
So if you don't have two terms, you will not think of the conjugate. First of all, secondly, you have to simplify everything. I was thinking that somebody will say this. Do not write this, please. This is what we always did from the beginning of this chapter. The square root of 4, or let me say the square root of 5 over the square root of 2 is the square root of 5 over 2. Although this is not useful now because I will not be able to simplify. But why? So this would have been the common sense to do. However, we are not allowed to do this because this property is valid only for real numbers. So if I have the square root of 4 divided by the square root of 9, I can write this. But if I have the square root of negative 4 over the square root of negative 9, I cannot write this. Why? Because these are complex numbers. They are not real numbers. They are complex numbers, not real. So this property works only for real numbers. Only for real numbers. Only. So therefore, you're correct. I cannot write this. I cannot do this. But what I can do is split it up. And that's exactly what we need to do. Into the square root of negative 1 times the square root of 80 over the square root of negative 1 times the square root of 10. And yes, now I can simplify these. I can simplify I with I. Now I can write this as the square root of 80 over 10. Because now I'm combining, I'm putting under the same square root two real numbers. And this will be the square root of 8, which we know from this chapter is the square root of 4 times the square root of 2. Therefore, the square root of 8 will be written as 2 the square root of 2. So 25 was a tricky question.
Can you keep that up for a second?
Sure. It could have trapped us into or lured us into writing something like this, and that would have been a mistake. Any questions? Okay, let me copy a couple of problems for you to work on. 73, which is 2 minus 3i over 2 plus I. And the other one is 86, which is I to the 40th power. Let me know if you need help.
What page is this on?
All on 640. I'm loading up your videos. Are they helping anybody?
They were until this.
I'm sorry?
They were until this one.
Okay. I'm sure that once you sit down and work on them, you will have no difficulties. I absolutely trust that. And I'm loading the first part because otherwise it takes so long. Do we have an answer for the first one? And for the second one? Yes, please.
Is it like a safe assumption to say that if the exponent is an odd number, it's going to be I, like the answer is going to be I? You know?
Or negative I, depending on.
Right. And then
Yes, you could find that pattern, but what I recommend is this. And you don't have to memorize anything. So it's an even number. You split it into 2 and 20. This will be your -1. -1 to the 20th is 1. But if you want to find patterns, I'm fine. That's fine. So the answer for your question is yes. But to be on the safe side, I would not do anything. Just remember I squared.
Got a question.
Please.
If say it's minus I squared, that would be 1, right?
Because it's minus, and because I squared is -1. -1 times -1 would be 1, yes.
Can you multiply I by -I?
Get 1.
Just 1.
So I multiplied by -I is -I squared. This is -1, so the answer is 1. Better? Okay, so in 73 we have 2 minus 3I over 2 plus I, and I have to multiply and divide by the conjugate, the complex conjugate of the denominator. What do I get in the denominator?
4 minus I squared.
Excellent. So now let's multiply here. 2 times 2 is 2 times -I. -3I times 2. -3I times 2. -6I. And -3I times -I. Sine. Sine. Good. Now I will replace these 2 by so now the denominator will be
5.
perfect. And the numerator, since this becomes -3, I have 4 minus 3, which is, and then I have -2I minus 6I.
8I.
Good. And now I have to split it into 1/5 minus 8/5 I. Allow me to recommend you have highlights on 1, 2, 3, 4 pages. Highlights from each section, what is important in each section, and examples in the book. I recommend between now and Thursday, work on problems from number 1 through 159 as much as you can on page 645, 646. This is a perfect review for the entire chapter. And don't forget chapter 9. So we will review on Thursday chapter 9, sections 2, 3, and 4, and all sections in chapter 7. If you, between now and Thursday, do at least 50 or 60% of these problems, you will be very well prepared for the test. So you're not going to learn again the material in class. You're going to be able to participate and ask a lot